Hello students, welcome to all of you in this lecture of transportation model. This is a part 2 of the transportation model. In the first part, we have already discussed that how to formulate the problem in a specified format and then how to get the initial feasible solution. And we use the three methods to get the initial feasible solution. First method was northwest corner method. Second method was least cost entry method, and third method was Vogel's approximation method. So with the help of these three methodologies, we get the initial feasible solution. When I talk about initial feasible solution, it means that the solution which satisfy the rim conditions, that means number of rows plus number of columns minus one. That means if there are three rows and three columns in our transportation table, then at least five allocation must be there by using any of these three methods. And today's lecture will be absolutely focused on how to test the optimality of the initial feasible solution, which we have got by using these three methodologies. So we'll be focusing on test of optimality. After that, we will be discussing how to make improvement in the transportation problem if the solution which we have got is not optimal solution. So that is the basic structure of today's lecture. So when I talk about testing of optimality, so optimality test, the foremost condition to test the optimality is that it is applicable only to the feasible solution consisting of m plus n minus 1. M here is the number of rows in the transportation table, n is the number of columns in the transportation table minus 1. So if there are three rows and three columns, at least five allocation should be there. So test is applicable only if the rim condition is satisfied and allocations should be in a independent position. So this is the one of the minimum requirement to take the optimality test. So we will be studying two methods which are widely used for testing the optimality of the transportation solution, initial feasible solutions. There are two methods. One is stepping stone method and second is modified distribution methods. And both the methods are basically the same methodology because both the methods focus on evaluating the unoccupied cells or the cells which has not been made any allocations. So we will try to find out if the allocations, even 1 unit of allocation is made in the unoccupied cell, if there is going to be any change. If the change is going to be positive, that means if it is going to increase the cost of total cost of the transportation, that means our solution is optimal. Because if it is going to decrease one allocation, it means there is a scope for improvement in the solution, in the initial feasible solution, which we have got by using the three methodologies. So stepping stone method and modified distribution methods are basically evaluating the scope of unoccupied cells, scope of allocating units to the unoccupied cell to find out whether is a improvement in the index. That means if we are going to decrease the cost, then it means there is a possibility of improvement. If we are not going to decrease the cost, it means there is no possibility of improvement and the solution we have got is optimal solution. So stepping stone method is basically helps us to find out the least cost solutions. And there is one very important rule to implement for that is the number of occupied routes. That means squares must always be equal to one less than the sum of number of rows plus the number of columns. That is the rim condition which we have already discussed. So in the initial solution must be, if there are three rows and three columns, 3 plus 3 minus 5 minus 1, that is the 5 square should be used. So occupied shipping routes in the transportation table should be number of rows plus number of columns minus 1. So one less should be there. So testing the solution for the possible improvement. So stepping stone method works by testing each unused square in the transportation table to see what would happen to total shipping cost if 1 unit of product were tentatively shipped on an unused route. So there are occupied cell, that is used route, if any cell is diverted to the unused route or unused cell, so if there is, that is going to decrease our cost, it means there is a possibility of improvement in our transportation solution, so that we will try to improve the solution with the help of one methodology. So as far as stepping stone method is concerned, it works by testing the each unused skewer. So both these methods, either it is modified distribution method or stepping stone method, basically both works by testing each unused skewer in the transportation table to find out the possibility of decreasing the cost. So there are 5 steps in the process which we will be studying to find out the optimality of the solution which we have got through the 3 methodologies of least cost entry method, northwest corner method, or Vogel's approximation method. So first of all, if the rim condition is satisfied, that means there is a solution, and that is feasible solution, and this is our initial feasible solution. So first, what we will do, there are 2 kinds of stones in a pond. The transportation table which has been prepared by us in a standard format, that is basically a pond, and there are certain stones. Stone mean occupied cells in that pond, and we have to shift the position of used or stones from one place to another place to unoccupied cell to find out whether there is a scope for improvement. So basically, first step will be select an unused skewer to evaluate. Second step will be from beginning to the unused skewer, trace a closed path back to the original skewer via skewers that are currently being used with horizontal or vertical move allowed. So here we will create a closed path, and while creating the closed path, we will take it caution that we will move either horizontally or vertically, but we will not move diagonally. We can cut the lines of used and unused skewers, but we will not move diagonally. So either we will move horizontally or either we will move vertically. So beginning, when we are found out a closed path, beginning with a plus sign at the unused skewer, place alternative sign minus and plus sign on each corner skewer of the closed path, just we have trade. So when we will do it practically, you will be more clear about it. And after that, then once we have created a closed path, we will calculate an improvement index by adding together the unit cost figures found in each skewer containing plus sign, and then subtracting the unit cost in each skewer containing the minus sign. So in this way, we will be able to find out the improvement index. So if the improvement index is positive, because I have already told you in the beginning of the first part of this transportation lecture that if a transportation model deals with the cost minimization problem. So if any scare is there, by allocating to that particular unit, if we are going to decrease our cost, that means minus improvement index is there. So it, minus sign is there by reducing the cost, that means we can improve the solution. But if all are positive, it means we have yet got the optimal solution, and there is no need for any improvement. So if improvement is possible, that means improvement index is shown negative by any of the cell, unoccupied cell, that means cost is going to reduce, then we will improve the solution. And if it is not there, then that means we have got the optimal solution. Then we will repeat 1 to 4 step until an improvement index has been calculated for all unused skewer. If all indices computed are greater than or equal to 0, that means an optimal solution has been reached. And if it is not, it is possible to improve the current solution and decrease total shipping cost. So in this way, we can decrease the current shipping cost. So there are 5 tests now. We will do it with the help of the example. Suppose this table is given to all of you. So here D, E, and F are the 3 factories, and there are 3 warehouses A, B, and C where you have to transport the goods. So by using any of the methodology, we have obtained this solution. Here the 3 rows are there and 3 columns are there. It means 5 allocation should be there, and we have 5 allocation in this table. For example, D to A we have 100 units. Similarly, E to A, we have 200 units. E to B, we have 100 units. And similarly, F to B, we have 100 units. And F to C, we have 100 units. So in this way, a primary allocation has been made by using any of the three methodologies. Now we have to test the optimality by using the stepping stone method. So I have already told you that this is a pond of table. Here, there are certain occupied cells. For example, DA, EA, EB, and similarly FB and FC are the occupied cell, and similarly there are unoccupied cell. For example, DB is there, DC is there, and similarly EC is there. They are unoccupied cells. Similarly, FA is unoccupied cell. So there are total 9 cells, out of which 5 are occupied and 4 are unoccupied. So now we will evaluate the position of the unoccupied cells, whether there is a possibility to improve the solution or not. If it is going to decrease our cost, that means we are in a position to improve the solution. But if all are positive, that means change in the cost is positive in the unoccupied cell also, it means the optimal solution has been achieved. So let's first of all, we will evaluate this first, uh, the unoccupied cell, that is DB. So this DB is an unoccupied cell, and we have to now move horizontally or diagonally to create a closed path. So here it is created. For example, we will move from B to A, and A to E, and E to B. So this is four, because we have to, once we have to start from the unoccupied cell and we will move in the occupied cells only. So closed path we will be creating. So let us take these 4 boxes out of this box. For example, we have created this. This table is short table is out of this total box. So these 4 boxes are there displayed to understand it more accurately. So let's see, now this is a path created. We will start from the unoccupied cell, that is warehouse B, and then we will move to the warehouse A. Then again we will move to the factory E, then factory E2, again we will move to the this warehouse B. So this is a closed path which is created. So we will start from the DB, and DB to we will move to the DA, then we will move to the FA, and then we will move to the EB. So this is a closed path which has been created. So now we will find out the change in the cost, because if 1 unit is allocated to this DB, it means we will be putting 4 rupees, $4 cost. And similarly, definitely, because we have to keep the demand and supply intact, we will not change that alter, because if 1 unit is allocated to D to DB, then we have to deduct 1 unit from DA. Similarly, if 1 unit is deducted from the DA, then we have to add 1 unit to the EA. Similarly, if 1 unit is added to the EA, then we have to deduct 1 unit from the EB. So in this way, plus minus sign has been put up. So now we will find out whether it is going to change our cost. So if 1 unit is allocated here, so it means because the total supply capacity of this factory is 100 units only, so it means we have to deduct here, because total can remain 100, so it will become 101, so we have to deduct it. So 1 unit is deducted and it will remain 99. And then if same here 99 is there, then total will have to be 300, so it means it will become 299, so we have to add 1 here, so 1 will be adding here, so it will be 201. Similarly here, if it is 1 is added, so total here cannot exceed 300, so here we have to deduct 1 unit. So in this way we will continue to find out to improve the find out if 1 unit is added, then how alteration will be made in other boxes of unoccupied cells. So now let's see. So this is the situation which will become, and we can find out the result of the proposed shift in allocation. If 1 unit is added here, so it means 4 rupees cost, $4 cost will be added. So if 1 unit is deducted from here, So here 5 rupees, $5 cost will be deducted. So if 1 unit is again added here in EA warehouse, so it means again 8 rupees cost will be added. So if 1 unit is again deducted from here, from this cell, so here $4 cost will be reduced. So ultimately plus 3 cost will be there. So it means we have evaluated this unoccupied cell and found that by allocating 1 units, our cost will be increased by $3. So it means this is not a viable solution. That earlier were having 3 rupees, $3 lesser cost. Now we are going to have more cost. Now, similarly, step 4, now we have find out that by allocating this unoccupied cell, we are going to increase our cost by $3. So similarly, we will find the others boxes. So for example, the next box unoccupied cell is this one. So we have calculated the path from this, and this path is also going to increase our cost by $4. Similarly, we moved to the other boxes, and we found that other boxes also, one box is going to increase our cost by $1, and another box is going to increase our decrease our cost by $2. So in all these positions, 5 positions, we have found that only one part is there which is going to reduce our cost by $2. So that is minus $2. So we will take this path and make the reallocations here. So now in the above problem, there is only one unused route with a negative index. And if there are more than one route with a negative index, we would choose the one with the largest improvements. So the largest negative value we will take, and in that big box, in that route, will be making the changes. So now we now want to ship the maximum allowable number of units to the new route. So the quantity to ship is found out by referring the closed path of the plus and minus sign for a new route and selecting smallest number found in these squares containing minus sign. So let us see how to do it. So how to improve the solution. So here, if you, this is the path where needs to be made improvement. So this is the unoccupied path. So we start from here. Here is a plus sign. Here is a minus sign. Here is again plus sign. Here is a minus sign. So we will be finding out the boxes with the minus occupied cells with the minus sign. So here it is 100. Here it is 200. So we will take the minimum. So this minimum will be deducted from the boxes having a minus sign and added to the boxes having a plus sign. So in this way, our new table will be like this. So this will change our box. For example, earlier in this box, we were having no occupied cell. So here 100 units, so 100 minus 100 will be 0, and here 200 minus 100, 100 will be there, and here wherever we have plus sign, we will add 100 units there. So 100, and here 0 was there, now here it will be 100. So new table will be like this. So this will be our new table. So in this way, again we will find out its cost. It is equal to 4,000 units. So similarly, we will again improve it, and after improvement we will get this kind of table, and here the total, again we will be evaluating all the paths by creating a closed path, and we find that we have got the optimal solution because all are actually has positive index. So it means all are greater than equal to or 0, and it means we have got the optimal solution. So in this way we will continue till we got all the improvement indices as positive, or yani, that is greater than or equal to 0. So we will continue with that. So this is the stepping stone method. So let us take another example before us. For example, this is an initial feasible solution before us. So we will be now, first we will be ensuring that there are 3 rows and 3 columns, so at least 5 allocations should be there. So there are allocations are 5, 1, 2, 3, 4, and 5. So now there are occupied cells 1, 2, 3, and here 4 unoccupied cells are there, and 5 occupied cells are there. So now we will, there are occupied cells which are unoccupied cells which are W. Here we can consider the unoccupied cell XC, this is 1. Second is YA, this is one. Then ZA, this is third, and we have ZB, this is fourth. So four unoccupied cells are there. So we will be evaluating each one by creating a closed path. So we have created all these chords. So XC, YA, ZB, and you can find that there is only one which is having negative, and that is 130. All others are positive. So in this way, we'll calculate. So then we have created this path which is having a negative. So one is given from unoccupied beginning, we will start with plus sign and then minus sign, then plus sign with minus sign. So we will find this cost. Sign can be assigned clockwise or anti-clockwise. So in this way, in this manner, then again we will revise the solution, and we'll continue to revise the solution till we get the optimal solution. So this was regarding the stepping stone method, in which a closed path is created for all unoccupied cells. Cost change is found out, or improvement index is found out. If all improvement index are greater than or equal to 0, our solution is optimal. If all are not greater than equal to 0, then we will be finding out the cell which is having negative minus sign, and then we will make alteration into that with the alternative plus and minus sign, and we will find out in the minus boxes what is the minimum allocation that will be deducted from the minus cells and added in the plus cells. So in this way, the improvement in the solution is made. Again, we will be testing its optimality, and we will continue till we get the optimal solution. Then another method is modified distribution method. And we have seen that in earlier stepping stone method, we have to create a closed path for every unoccupied cell. And sometimes it becomes difficult. If there are large number of cells, then it is very difficult to come out with these boxes and make calculations. So modified distribution method allow us to compute improvement indices more quickly for each unused cure without drawing all the closed paths. So here there is no need to draw all the closed paths. So because of this, it can often provide considerable time saving over the stepping stone method for solving transportation models. So if there is a negative improvement index, then only one stepping stone path must be found. So this is used in the same manner as we obtain an improved solution. So let us take an example. Let us take same example which is given here. There are three cells, and now we have to evaluate each and every unoccupied cells. First, what we will do, we will give the R1, R2, and R3 as the number of rows, and K1, K2, and K3 as the number of columns. So same other table is prepared. So now we'll be first evaluating this one. DB, which we have to evaluate. So first we will do, we will make equations of the occupied cell. So we will make equations of the occupied cell. What are the equations? R1 K1, this is one equation. Similarly, R2 K1, this is second equation. This is R2 K2, this is third equation. And then R3 K2 as the fourth equation, and R3 K3 as the fifth equation. So five equations, because five allocations are there. So we will first make equations of five allocated cells. So how this will be made? So let us see toward that. So here, for example, the first step is to set up an equation for each occupied cells. So by setting, so these are the equations we have calculated. For example, R1, let us move back to again that table. So here R1 plus K1 is equal to the cost factor, that is $5. So R1 plus K1 is equal to 5. So similarly, second will be R2 plus K1 is equal to 8. And thirdly, R3 plus K3 is equal to 7, and similarly R3 plus K3 is equal to 5. So these are the five equations which we have got. So now we will presume R1 is equal to 0. We will find out the value of K1. Similarly, we will find out the value of, because K1 has been found out, you can find out the value of the R2. Similarly, R1, R2, R3, R4, and K1, K2, K3, all values will be find out. Now we have to find out the change in the cost of the unoccupied cell. And for that purpose, we will use this formula. That is the cost of that unoccupied cell minus Ri minus Kj. For example, if you have to evaluate this one cell, first cell, this one, that is here the cost factor is 4 minus R1 value minus K2 value. So in this way, we will be finding out the change in the cost. So C12 minus R1 minus K2 value, and this for $3 has been found out. Similarly, other cells will be calculated with the use of these equations. So this is an easy way. Here we are not required to create the closed path for every unoccupied cell. So we'll be finding out the closed path for only that cell which has a negative improvement index, and that is FA. So we'll again move to FA in the table, and here it is FA. So for this cell only, we will be creating the path and finding out how to make improvement. So here it will be plus sign, here it will be minus sign, again plus and again minus. So here again same way, the same change has been there. So it means out of these two minus, we have 100 as a minimum. So we will deduct from the minus places and add 100 to the plus places, and then new solution will be arrived at. So let's move to that again table. So in this way, we will improve our solution. So this will continue till we got the optimal solution. So let's take an example of one more question. So this is a transportation problem which is given to us where demand and supply are equal. So 8 is there, here it is also 8. So first we make allocation by WAM. We have made the allocation through WAM. So now there are 1, 2, 3, 4 and 5 allocations, and 4 unoccupied cells are there. So now we have to evaluate the position of the unoccupied cell. Again, we will be using that methodology. So R1, R2, R3, and similarly K1, K2, K3 will be giving the value. So similarly, here C1, C2, C3 has been used. So keep taking R1 value as 0, we'll be finding out the values of others. So now we have to evaluate the unoccupied cell. The first unoccupied cell which is given in this table is here, for example, R1 and this C3. So here the cost is 3 minus R1 value is 0, and similarly C2 value will deduct and find out the uh, cost change. So we find that all are positive and 0. So it means the optimal solution has been obtained. So by using the this methodology of modified distribution method, you can use the methodology to improve our solutions. So these are the two methods which are used for improvement or testing the optimality of our solution. So this was all for today. Thank you very much.